Okay, so we're just going to prove that the left-hand side matches the right-hand side. So first thing that we're going to be doing is we're going to start with the left-hand side. I'm only setting it out like this because, like, normally I would solve left-hand side and right-hand side at the same time. I'm setting it out like this because it doesn't really fit all the way across the page when I'm writing on this little notebook thing. So we're going to start with left-hand side, which is z minus w squared. Now, first thing that we want to do is we want to put the z back in and the w back in. So that's going to be equal to a plus bi minus c plus di. And we're going to be taking the magnitude of that and squaring it. So all I need to do here, start grouping my like terms. So I'm going to group the real component, AC, plus b minus d, and that's I, and that's still squared. Now, when I take the magnitude of these, it just means that I'm going to knock out that and the I component. So it'll be a minus c plus b minus d, and both of those parts are going to be squared. Okay, so now all that's left to do is expand the brackets. So a squared, now remember that squared means a minus c multiplied by a minus c. So you don't just go this one squared, that one squared. You do this times this times that, which means our middle terms will become 2ac plus c squared. And then the same thing for the other side, plus b squared minus 2bd plus d squared. So that is our left-hand side fully expanded. Now we're going to look at our right-hand side. We're going to try and make them match up. So z squared plus w squared minus 2 lots of the real component of z w conjugate. So first thing I'm going to do is I'm going to input my equations in there. Plus c plus di minus 2 lots of the real component of a plus bi. Now the conjugate here is going to be c minus di. Remember, the purpose of the conjugate is to flip it over the axis. So when I square this, I'll end up with a squared plus b squared, and then when I do this part, I'll end up with c squared plus d squared, and then when I take 2 lots of, now we're looking for the real component, so when I expand these brackets out, I'll end up with ac minus adi plus bci minus dbi squared. So these two terms in the middle are imaginary, which means they're not getting included. When I take the real components, I'm only taking the AC part forward, and I'm going to take the dbi squared, because this will become -1, meaning that that will become plus db. So plus db. Okay, so now I'm going to expand out these brackets. I'm going to set it out the same as this. So that'll become a squared minus 2ac plus c squared plus b squared minus 2bd plus d squared. So I've written it out so that it matches this line up here, because that will allow me to make my statement of, therefore, left-hand side is equal to right-hand side, so true. Now, if I'm breaking down where your marks have been laid out for this one, you get 1 mark for this final statement, 1 mark for showing that they are the same, 1 mark for expanding out or identifying this line here, including the conjugate on that one. This one up here, you get 1 mark for that part, 1 mark for substituting these parts in and grouping them into their correct parts. So that's 1, 2, 3, 4, 5. And must be 1 part for ignoring the reals, the imaginary components.